Bismillah ar-Rahman ar-Rahim. Now we'll continue doing the sections after the second exam. This is the first section, 8.8 Improper Integrals. What do you mean? What's improper integrals, or what we did until now? We are talking about integral, like integral, definite integrals. We talk about the definite integrals. We have the function continuous on a closed interval. Okay. Now, they call it proper integrals. Improper integrals, we have usually two cases. The first case, if the interval of integration is infinite, it has infinity or minus infinity. There's infinity or minus infinity in one of the limits of the integration. The second one, the integrand has infinite discontinuity on the interval. Example, this one, we have infinity. So we call it improper integral. This one, I have a problem at x equal 1. So because of that, because it's not defined, the function is not continuous at x equal 1. Actually, it's not defined also at x equal 1. So we call it in improper integrals. We have infinite discontinuity. And also it's infinite discontinuity. This is important. It's not only any discontinuity. I need the infinite discontinuity. Okay. This one we have minus infinity. Yeah. This will be the cases. Oh, actually, this is for two reasons. For minus infinity, and also at x equal 1, we have infinite discontinuity. So we have two reasons. Okay. This is what they mean by improper integrals. We'll talk about as two cases. The first one, if you have in the interval of integration, we have infinity or minus infinity. This is the first case. So say if it's continuous in this interval, then this integral, what I will do, just I will change this infinity to b or t or a variable, and I'll take the limit as that variable goes to infinity, and I'll do the integration regularly. Then I will do the limit. So it will be two things: integration and the limits. Minus infinity, the same thing, but now I will take the lower limit and make it goes to minus infinity. I give it a name. You can call it A, call it B, call it any way you like. Yeah, for sure, different than this one. If this is B, I cannot call this one B. So A goes to minus infinity, and then I do the integration, and after I finish, I do the limit. If it is from minus infinity to infinity, what I will do, I will split this integral into two integrals. From minus infinity to a value C is any real number, and this is from C to infinity. Usually take 0, but you can take any value. When we say it's converge, if the limit exists. If the limit does not exist, we say the improper integral diverges. This is the first two cases. The third case, if one of these integrals diverge, then we call them improper integral diverge. If both converge, then we calculate it. Example, I want to find actually up to infinity, from 1 to infinity of this integral. Let us see what will happen. What I will do, as we said there, just I will change it into limit. So we say limit, usually I use t, goes to infinity, 1 to t, dx over x. That's it. Then it means it has two parts, integration and then limit. So leave the limit. Let me do the integration. What will the integration? Dx over x, I know it. It's in absolute value of x. That from where to where? From 1 to t. So that will be limit. T goes to infinity. Do the calculation. I have ln t, an absolute value of t. minus ln 1. What is ln 1? 0. So that will be limit t goes to infinity, ln absolute value of t. Now I deal with the problem as a limit problem. I'm done with the integration. So now I deal with it as a limit problem. What will be limit of ln infinity? It will be infinity. So this integral diverges. That's mainly the idea. The rest is just calculation. I'm going to do the first one, 0 to infinity. Okay. So what I will do, limit e goes to infinity. Let me write it first. 0 to infinity is minus x dx. That will be limit t goes to infinity. Integral 0 to t is minus x dx. As I said, now first we'll start with the limit with the integration problem. So I have limit t goes to infinity of what? Of what's the integral of this? It's minus is minus x from 0 to t. That will be limit t goes to infinity of what? Minus is minus t. Yeah. Minus a is 0. Yeah, just to make it clear. That will be limit t goes to infinity of what? Minus is minus t. E is 0 is 1 minus minus. That will be plus 1. So now this is a limit problem. Is minus infinity is 0, so that will be 0 plus 1. It will be 1. That's it. Just a limit problem. Part B. What's the integral? 0 to infinity dx over x squared plus 1. That will be what? Limit t goes to infinity 0 to t dx over 1 plus x squared plus 1. Do the calculation. I have the limit. What is this? This is tan inverse of x. From where to where? From 0 to t. That will be limit t goes to infinity tan inverse of t. Tan inverse of 0 is 0. Now it's just a limit problem. Tan inverse of infinity is what? Pi over 2. And that will be the answer. These are the answers. That's it. So there is nothing to worry about. Just you do the integration, then you change the problem to limit problem, and that's it. This one, first I'll change it into the definition. T goes to infinity. 1 to t. 1 minus x is minus x dx. Now, how to find this integral? I need now the methods. An integration by parts. Actually, the tabular will do it. So I have 1 minus x is minus x. I have minus 1 minus is minus x. This is 0. This is integral is minus x. That will be plus. That will be minus. So still the limit is there. T goes to infinity. What? That will be what? 1 minus 1 minus x is minus x. Yeah. Then plus is minus x. This is from 1 to t. That will be limit t goes to infinity. Let me be careful with the calculation. Minus is minus x. Minus times minus plus x is minus x. Plus is minus x. No. Sorry. Yeah. Let me do it in steps. No problem. I'm just simplifying this from 1 to t. That will be limit t goes to infinity. Cancelled. So I have x is minus x from 1 to t. That will be limit. That will be limit. T goes to infinity. Of what? Now substitute the t. T is minus t minus is minus 1. Now it's a limit problem. How to do this limit? It will be infinity times 0, which is the undetermined form. So to do this limit, let me do it here. I need Lubither's rule. Limit t goes to infinity. T is minus t. It will be infinity times 0. I need Lubither's rule here. So it will be limit t goes to infinity. T over e to the power t. And that is what? Infinity over infinity. So do Lubither's rule. Differentiate 1 over e to the power t. I'm doing Lubither's rule. No? So what you are getting? 0. So this is 0 minus e is minus 1. So the answer is minus 1 over e, which is this one. As I said, it's only, you will do the same thing, the integration, but you need to be careful with the limit. This one, I have what? Two things, minus infinity and I have infinity. So you need to be careful. So this one, I will split it into minus infinity to infinity to 0 to a value, make it 0. It's up to you. You can put c, any value. Let me take 0. Now I need to do both integrals. So the first one, let me do it in the steps. I want to do this one. That will be what? That will be limit as t goes to minus infinity, t to 0. And that is equal to limit t goes to minus infinity. How to find this integral? I can let u equal e to the power x. Then what I will get? Integral e to the power t, e to the power 0, that will be 1 of u. D will be what? Ax dx. So it will be du over 1 plus u square. Yeah. That will be what? Limit e goes to minus infinity of what? Of, this is tan inverse of x from et to 1. That gives me limit t goes to minus infinity of what? Tan inverse of 1 pi over 4 minus tan inverse 80. Okay. Now what I have? Tan inverse of e is minus infinity. I know tan inverse, the function is to draw the function here, just to remind you. So as x goes to minus infinity, this one goes to minus pi over 2. So the answer is pi over 4 minus pi over 2. And that is 3 pi over 4. Okay. Yeah. Now let me do the other one. Limit as t goes to infinity of what? No, let me do it. Integral 0 to infinity e to the power x over 1 plus e to the power 2x dx. That will be limit t goes to infinity, integral 0 to t, ex 1 plus e to x dx. We did the integration before. I know it will be what? Tan inverse. Yeah. It will be tan inverse of x, where it goes from e to the power t, from 1. It will be from 0 to e to the power t. Or you can do the calculation again. That give me what? Limit t goes to infinity of tan inverse e to the power t minus tan inverse of 0. Sorry, this is 1. No, I change, you know what? Yeah, e to the power t to 1. Tan inverse of 1, tan inverse of e to the power t. That will be what? E to the power infinity, infinity. Sorry. This is wrong. Now, as t goes to minus infinity, e minus t goes to what? E to the power t. E to the power t goes to 0. So actually I need tan inverse of 0 here. That will be pi over 4 minus tan inverse of 0. And what is tan inverse of 0? 0, so that will be pi over 4. Sorry about that. Don't rush it. Now this one is what? Tan inverse of e to the power infinity, which is infinity. So that will be tan inverse of infinity, which is pi over 2. So that will be pi over 2 minus pi over 4. So the answer is pi over 4. So this integral is pi over 4 plus pi over 4. And that will be pi over 2. Okay. Yeah, be careful when you do the limit. Huh? I have e to the power minus infinity. It's not tan inverse of minus infinity. Don't rush it. E minus infinity will go to 0. So tan inverse of 0 is 0. Here I have, let me state it here. If t goes to infinity, e to the power t goes to what? Goes to infinity. So I have tan inverse of infinity, which is pi over 2. That will make it. As I said, it's only, you need to do integration, you need to do limits. You need to be careful. It's only a matter of calculation. This one, I will do it. I have what? An integral from minus infinity to 0, x e to the power x dx. That will be limit t goes to minus infinity, t to 0, x ax dx. How to find this integration? Integration by parts or tabular. I have x10, e to the power x, e to the power x, e to the power x. That plus, that is minus. So it's limit t goes to infinity, t goes to minus infinity. Be careful. Minus infinity of what? This integral is x e to the power x minus e to the power x Don't forget from t to 0. That will be limit t goes to minus infinity. Substitute 0 e to the, this will be minus 1 minus t e to the power t minus e to the power t. Now I need to do this limit, especially this. So let me do it. I think I need to do it as rule. T goes to minus infinity, TET. That will be what? It's minus infinity times 0. So I need Lewitter's rule. I will do it easily. As what? T over E is minus T. Now this will be infinity over infinity. So do Lewitter's rule. You get what? 1 over minus E is minus T. So it will be 1 over infinity, which is 0. So this is will be what? That will be minus 1 minus, this is 0. E is minus infinity, also 0. So the answer is minus. So it converges, and its value is minus 1. Yeah, and usually we say it converges. Huh? So we say the integral converges, its value is pi over 2. The same thing here, we say converges. Huh? And we say the integral, this integral converges, and its value is this. Here we say converges. I think both are converges. Yeah, converges. The first one, I think, it was diverges. Very clear. Diverges. Okay. So this one, we say it's converges, and its value is this. This one, let me do the calculation. I have integral from 0 to infinity. As I said, it's only a matter of integration and limit, both. So that will be what? Limit t goes to infinity, integral from 0 to t to x over 1 plus x squared dx. You need to do this integration. How to do it? You let u 1 plus x squared du will be what? Will be 2x dx. So I have limit. Sometimes it's not bad if you do the integration without these limits, without this integration limits, and then return it back, or you can do it at the same time to avoid doing the changes of the limits, sometimes with the substitution. Okay, that will be what? X equals to, that will be 1. Then you have what? 1 plus t squared. Okay, du over u. And that will be limit t goes to infinity of what? Of ln absolute value of u for where to where? 1 to 1 plus t squared. That will be limit t goes to infinity. Ln 1 plus t squared is always positive. Minus ln 1, which is 0. So what is this limit? Infinity squared is infinity, plus 1 is infinity, ln infinity is infinity. So it will diverge. Question. This one. Okay. I need to split it as usual. Minus infinity to infinity. 1 over 1 plus x squared dx. That will be what? Minus infinity to 0. Usually you use 0. It's a good, yeah, usually it's a good number to choose. Yeah. The calculation will be easier. So we'll do integration now. The first one. That give me what? This I know it. No, this is the first I changed into limit. T goes to minus infinity. Be careful the calculation. T to 0. dx over 1 plus x squared. This is will be limit t goes to minus infinity of what? Tan inverse of x from t to 0. That will be limit t goes to minus infinity. Tan inverse of 0 is 0. Tan inverse of 0 is 0. And then it will be 0 minus tan inverse of t. That will be equal to what? 0 gun tan inverse of minus infinity is minus pi over 2. So that will be pi over 2. So I have minus of minus pi over 2. This is tan inverse, huh? Okay. Yeah. As t goes to minus infinity, tan inverse of t goes to minus pi over 2. Half minus minus, so that will make it. Now from 0 to infinity, dx over 1 plus x squared, that will be limit t goes to infinity of what? 0 to t, dx over 1 plus x squared. That will be limit t goes to infinity of what? This is tan inverse of x from where to where? From 0 to t. Substitute, that will be limit t goes to infinity, tan inverse of t. Tan inverse of 0, 0. That will be pi over 2. So this one will be pi over 2 plus pi over 2. And that is pi. So the integral converges and its value is here. T goes to infinity. Tan inverse of t goes to pi over 2. And that's clear from the graph. Okay, let me do more problems. For what values of p is the integral convergent? Okay, let us do the calculation. Limit. Okay, t goes to infinity. 1 to t. Let me first write the problem. 1 to infinity. dx over x to the power p. Okay, that will be limit t goes to infinity. 1 to t. dx x to the power p. How to do this integral? Yeah, in the cases, if p equal 1, then I have what limit t goes to infinity, 1 to t, dx over x. And that I know it will be limit t goes to infinity, ln absolute value of x, that will be ln absolute value of x from 1 to t. That will be limit t goes to infinity, I'm doing it in details, ln t, ln absolute value of t, minus ln 1, which is 0. And that will be infinity. So if p equal 1, diverges. Now if p is not equal to 1, what will happen? Because I can't do the integration if I can do the integration if I make it in these two cases. Because if p not equal to 1, I can't do this power rule. Now, but if p equal 1, it's the ln. Okay, because that I split it into these two cases. Then what will happen? I have limit t goes to infinity. What will be this integral? Let me write it this way. 1 to t x to the power minus b dx. That will be limit t goes to infinity. What is this integral? It will be x minus b plus 1 over minus b plus 1. From where to where? From 1 to t. Okay. That equal limit t goes to infinity of what? T to the power minus b plus 1 over, you make it 1 minus b, better, over 1 minus b minus, if x equal 1, that will be 1 over 1 minus b. Now I need to deal with this limit. Let me do this limit here. Limit t to the power 1 minus b as t goes to infinity. This will be what? Avoid the case b equal 1. I know if this is positive, this is, we have two cases. This is if 1 minus b positive, then you have infinity to the power, to the positive power, that will be infinity. And that will be divergence, either infinity or minus infinity. Yeah, it goes, t goes to infinity. So yeah, for sure it will be infinity. If 1 minus b is negative, so I have, so it will be 1 over infinity, that will be 0. That means if b less than 1, huh? If b less than 1. And this is if b greater than 1. Okay, so that will give me what? That will give me this rule. If b greater than 1, it diverge. Now that means if b greater than 1, so we have this case. So this limit will be 0. We call it I. Let me use this I. Then I is to do all of this, then it will be limit of what? 0 minus 1 over 1 minus b, which is 1 over b minus 1. Yeah. If b less than 1, then what will happen to this? It will go to infinity. Diverges. And that we have this conclusion. If I have x to the power p, so 1 over p minus 1, if p is greater than 1, and diverges if b greater than or equal to 1, because the equality also is there. So conclusion, let me write it here. As above, 1 to infinity, dx over x to the power b, because I will use this later. That will be what? I have two cases. If b greater than 1, the answer is 1 over p minus 1. If b less than or equal to 1, that will be diverges. Yeah, which is the same as with it. Now, this is just quickly. Now, p is what? 4.9 greater than 1. Yes. So what is the answer? Right away, 1 over p minus 1, which is 1 over 3.9, which is 10 over 39. That's it. Yeah. Is it 1 to infinity? xp 1 over p minus 1. P is 4.9. This one, let me do it here. I need more space for the last one. That will be 1 to infinity. 1 over x to the power half. That's x to the power half. So what is p? Half less than 1. Right away, this is what? diverges. I have P less than 1, diverges. Now I did this from 1 to infinity. Will that make a change? Yes, especially for this one. When I substitute the 1, that's the only change. Okay, so let me do this from scratch, the last one. I have P here, by the way. P is what? 2, greater than 1. So converges. Converges to what? Is not 1 over P minus 1. Let us see it. So I have 0.5 to infinity, 1 over x squared dx. That will be limit t goes to infinity. Goes to infinity, 0.5 to t, 1 over x squared dx. I need to do this integration. That will be what? Limit t goes to infinity, minus 1 over x, 0.5 to t. Okay. Minus, yeah, x to the power minus 2, yeah, it will minus 1 over x. That will be what? Limit t goes to infinity of what? Now substitute, you have minus 1 over t minus, be careful here, minus 1 over half. So that will be limit t goes to infinity, minus 1 over t, minus 1 over half, that will be 2, with the minus, that will be plus 2. What is this limit? 2. So it converges, and its value is 2. If I use 1 over p minus 1, what I will get? 1 over half minus 1. That will be 1 over. I'm getting minus 2, which is wrong. So be careful. If it is 0.5, I think we need to be careful a little bit. Yeah. Yeah, when I substitute 0.5, I'm getting 0.5 to the power minus 1 over 0.5, the minus sign. Be careful. 1 over, that will be minus 1 over x. Correct. From t, I have minus 1 over t minus, substitute 0.5 there over half. Yeah, it's correct. That's equal to. Okay. The last one, the solid formed by revolving about the x-axis and bounded region. Okay. Find what? He said what? This solid has a finite volume and infinite surface area. So I need to find the volume and the surface area. Okay. Okay. So for the volume, it's about what? Revolving about what? The x-axis. And this is 1 over x. So I need to do the formula. This is 1 over x. From where to where? From 1 to infinity. From 1 to infinity. Okay. So, and revolving about the x-axis. So take, this is my region from 1 to infinity. So I'm talking about this region. Starting from 1 here. Okay. So I'll take the strip. This is my strip. Okay. So it is the volume. The volume will be V is the volume and S the surface area. Okay. So the volume will be pi from where to where? From 1 to infinity. Since he says x greater than or equal to 1. And 1 over x squared. And I have r of x. Huh? R of x is 1 over x. So I have r squared, which is 1 over x squared dx. I need this. Yeah. That will be what? I know this is 1 over x squared. I know it from here. 1 over x squared. So p is 2. It's 1 to infinity, so I can do this. So that will be pi 1 over 2 minus 1. And the answer is pi. That will be the volume. So it's finite volume. It's finite volume. Okay. So the integral converges and it's a finite. What about the surface area? The surface area will be what? Will be the integral from 1 to infinity 2 pi times what? Times y square root 1 plus, yeah, I need f prime, f or y, let me call it y equal 1 over x. What will be y prime? Minus 1 over x squared. I need this one squared. Huh? I need y prime squared, which is 1 over x to the power 4. So that will be 1 over 1 plus x to the power 4 dx. So that will be 1 to the power infinity 2 pi. Let me take 2 pi outside. 1 to infinity 1 over x square root 1 plus 1 over x to the power 4 dx. Not easy to calculate. Yeah. You can calculate it, but it will be not easy. But you can figure out something. You know the integral 1 to infinity 1 over x dx. This is diverges. Actually goes to infinity. We know it from here. If p equal 1, I'm getting what? Infinity. And I know, this one is greater than 1. So infinity times a value or goes to infinity greater than 1, for sure I'm getting diverges. So we have infinite surface area. Infinite surface area. I think this is enough for the first case, which is, what is the case? Let me go back. If you have infinity in the limits of integration, or of both, the same thing. Okay, be careful. If you have it in both, if one of them is divergent, that's it. It means the improper integral diverges when either of the improper integrals in the right. Yeah, let me stop the recording, then we'll do the next case in the next video. Let me stop the recording. Thank you.